Hello guys, this is Avinash and you're watching Everything Metallurgy. So guys, first of all, a huge thanks to one and all for this 1,000 subscriber milestone. We have reached this one day before. So thank you one and all for sharing and watching my content. So this is a different sort of a video generally. This is not any lecture, but I wanted to explain or give a brief analysis of how gate paper can be observed. Okay, so this is a gate you can call an overview video. Okay, so in this video we'll see how the gate paper weightage will be there. Okay, so firstly we all know gate is for 100 marks. Any gate paper is of 100 marks. Okay, and this is divided into two sections. Okay, one is general aptitude and the other one is technical. Okay, so here the general aptitude section consists of 15 marks and this technical will be of 85 marks. Okay, and here also the 100 marks totally are divided into two sections. Those are nothing but 1 mark questions and 2 mark questions. Okay, so in this general aptitude section you'll get 5 1-mark question and 5 2-mark questions. Okay, so whereas here we'll be getting a 25 1-mark questions and 30 2-mark questions. Okay, so in the questions, if you see, the general aptitude section is of 10 questions and the technical side is of 55 questions. So totally 100 marks, there will be 65 questions in our gate paper. Okay, now general aptitude, we know this is common for all the subjects, all the gate papers. Now we are mainly bothered about the technical side of our metallurgy paper. Okay, so technical 85 marks or the technical 55 questions are divided into 6 different sections. Okay, the technical section or the technical part of the gate paper consists of 6 different sections. Okay, out of which the first important one is engineering mathematics. Okay, this is again the common subject for all the gate papers. In this, you will be observing different chapters like linear algebra, differential equations, calculus, both integral as well as vector calculus, numerical analysis, and obviously probability. Okay, so these are the different sections. Linear algebra is nothing but matrices. Okay, so engineering mathematics usually consists of about 13 to 15 marks. So this is not a joke. 13 to 15 marks is a huge amount of marks. Okay, so this 13 to 15 marks you can easily score by studying all these different sections. And you know, gate maths in metallurgy is easy as compared to others. So if you can do all the previous year problems and all, and remember the formula based questions will be there. So by remembering the formula, you can easily score a good amount of marks in this section. So this is engineering mathematics. Next come the core technical part. Okay, the core technical part, which the first one is thermodynamics. thermodynamics and rate process. Okay, so this is a section in which there is a huge chunk of marks are there for this section. The weightage of this will be about 18 to 20 marks. That means all in all about 1/5 of the total marks you can score if you do well in this subject. Okay, so here also there are different sections or different topics. The first one is basic metallurgical thermodynamics. Those are nothing but the laws, first law, second law, third law, solutions, and all this stuff. Next is electrochemistry, and the third is heat transfer, and also there is other section that is mass and momentum transfer. Okay, so in this topic also the most easy and important topics are heat treatment and the laws, first law, second law, third law. Okay, if you can concentrate more on heat transfer, there will be definitely 3 to 4 marks from heat transfer, 3 to 4 marks from mass and momentum transfer, and here you can find 5 marks from electrochemistry, and here about 5 to 6 marks from this. This metallurgical thermodynamics section is very vast, very huge. Okay, so if you concentrate, as we have about only 20-25 days away from the gate exam, if you concentrate on these two topics, electrochemistry and heat transfer, these are about half of the marks that you can score from thermodynamics and rate process. But why I am telling to cover these two first is because the weightage is about 8 marks, and also these are small topics. Okay, these are very small topics. If you see where to study this electrochemistry, you can study this from Callister. There is only one single chapter named electrochemistry, okay, or corrosion. So you can refer Callister, and heat transfer also you can refer any type of book, okay, any heat transfer book, and it has only 3 types, right? 3 modes of heat transfer: conduction, convection, and radiation. Okay, conduction there will be Fourier's law, convection there will be Newton's law of cooling, and in radiation you can see Stephen's law or Stephen Boltzmann's law. Okay, so by studying these, usually they are all formula based questions, so that is why I'm focusing to go with these two first, and then you must study the metallurgical thermodynamics, because that is the basics of thermodynamics, the first law, second law, third law, zeroth law, and also the next one is solutions part. Okay, all usually this thermodynamics is problematic. Okay, there is a chance of more numericals coming from these sections, so try to study formula from the previous year questions and do solve more number of previous year questions. Okay, this is about thermodynamics and rate process and the different sections, and the weightage, overall weightage is about 18 to 20 marks. The next section will be mechanical metallurgy. Mechanical metallurgy. The weightage of mechanical metallurgy will be about 14 to 15 marks. And all these weightages I have analyzed the 2016, 17 and 18 year paper, and I'm just telling this to you. Okay, so it may vary plus or minus 1 or 2 marks, but usually this will be the weightage given in the gate examination. So here also there are some important parts. The first one is yield criteria and plasticity. The next is mechanical testing. And the next one is fracture and fracture mechanics. Okay, so these three are the important, all the three topics are important, and the most important one is the mechanical testing, which, and the important topics in mechanical testing are tension test, DBDT, that is impact test, fatigue and creep, and also hardness tests. Okay, and also hardness tests are important. And here in fracture and fracture mechanics also, Griffith theory of brittle fracture is very, very important. Griffith theory, and this is one of the biggest or vast topics of mechanical metallurgy, where you will be getting to study about lots and lots of basics and relations between stress, strain, yield criteria, yield phenomena, CRSS, all these important topics for gate examination. And generally this is a mix of theory plus numerical. But what I have observed is about 8 to 10 marks are coming from numericals and the rest is theory. So here also in this section also don't lose silly marks, because this is, I think this is the easiest section and scoring part in the gate metallurgy examination. So as I already said, in this first topic also the important topics are CRSS, yield criteria, mode circle, yield phenomena, the relations between stress, strain, true stress, engineering strain, etc., and their relations. Okay, so you have to take care of each and every formula that is coming from this, and for this you can follow the book Dieter. Dieter is a very famous book that is used in our metallurgical engineering degree. Okay, but Dieter, I just want to give a bonus tip that Dieter is very, very lengthy. Okay, GATE is an examination in which you have to know what topic to study and what topic to leave. Okay, so you must be smart enough now, because there is very less time, there is a time constraint now. So be smart enough and pick up the topics or study. If you are starting out from this Dieter, then I suggest you to note down all the important formulae first. Okay, so this is about mechanical metallurgy, where you'll be getting about 14 to 15 marks. The next important one is physical metallurgy. The next important part is physical metallurgy. So again, this is also about 14 to 15 marks. Okay, this topic also comes from for about 14 to 15 marks. Fine. The next one will be, the topics in this physical metallurgy will be, the first one and important one is crystal structures. And again, physical metallurgy is a very vast section of this syllabus. Crystal structure. The next one is phase transformations and also phase diagrams. Material characterization. And finally, the properties of materials. Okay, the properties of materials. So this is again, as I said, one of the biggest or the vast section of our gate metallurgy topics. Crystal structure is very important. This is the basic, all linear densities, planar densities, Miller indices, how you must know how to draw what type of plane, slip systems, deformations. Okay, deformation, in this location theory you will be studying deformation in the mechanical metallurgy part, but which is the slip system, what are the number of slip systems, and all this stuff you will be studying in this crystal structure. Okay, so crystal structure is important, whereas here in phase diagrams and phase transformations, the heat treatments, all the type of heat treatments, you must know basic idea about what are the different types of heat treatments that are available for the phase transformations, and also the phase diagrams. Phase diagrams, usually iron carbon diagram is very important, and here lever rule, you must know how to calculate the amount of phases. Okay, you must be able to calculate the amount of phases that are present at different percentage of carbon or any solute atom, that you will be doing by Riemann rule. And also here nucleation and growth is one of the important topic in this um, solid solution part. Okay, now coming to material characterization, XRD is one of the important thing. Okay, so you must study XRD completely from the theory as well as doing the calculating the angles. Okay, at what intensity you will be getting, what are the peaks, what are the different peaks you will be getting at different angles. Okay, with the use of Bragg's law, you have to calculate all this stuff. Okay, so Bragg's law from XRD is a very important topic. And the next properties of materials are nothing but the important properties like electrical, magnetic, okay, thermal properties. All these are very important, and these you can study from the book Callister. Okay, apart from this, there are some miscellaneous topics like polymers and composites. Okay, in composites, usually there will be a question of calculating the Young's modulus, okay, in the two orientations, either lateral or longitudinal. Whereas in polymers also you have to calculate the number molecular weight or the weight molecular weights and all those stuff. Okay, so you must be able to know the difference between all this stuff. So all this you can also study from Callister. Okay, so this is about physical metallurgy, where the overall weightage varies between about 14 to 15 marks. Okay, the next important section is extraction. Okay, many may say extraction is the least important topic. Yes, obviously in marks, if you see, this will be only about 6 to 7 marks, or maybe 6 to 8 marks, not more than that. Okay, so in extraction metallurgy, there are topics like iron making, steel making, and non-ferrous extraction. Okay, so I am now making videos on this non-ferrous extraction, but you can just click on this iCard to get the playlist of this iron making, and also I'll be giving the iCards for the videos that I have made on the steel making. Okay, so here iron making and steel making, you can follow my videos or you can follow any standard book, but the thing is you have to do the problems from the previous years first. Okay, what are the problems? First one is material balance, and the next is the partition coefficient models. Okay, each one is from each one. So material balance is of iron making, partition coefficient, sums are of steel making. And coming to this non-ferrous extraction part, this non-ferrous extraction is, you must know the basics of every metal. What is the ore of each important metal, each precious metal, and how that is getting extracted. That means what is the most economic and what is universally adopted methods of each metal, that you must know. At least you must know for aluminium, copper, lead, zinc, titanium, and nickel. Okay, so these are the important metals, non-ferrous metals that are useful. Okay, so these are these things. So now what else is left? The most important part, and which is common for both mechanical students as well as us, is this part, that is manufacturing, or you can also call production. Okay, manufacturing or production. So here again we'll be writing the different sections here. Manufacturing processes. You will be getting about 8 to 10 marks. Okay, sometimes it is actually 8 to 12 also sometimes. So here the different topics are metal casting, welding, metal forming, and the other topics NDT and powder metallurgy. Okay, so here definitely NDT you will be getting 1 mark and powder metallurgy you will be getting 2 to 3 marks. So don't neglect these, because in powder metallurgy there are only few formula like densification parameter, or they'll be asking to calculate the neck size. Okay, neck size or densification parameter. Okay, and some basic 1 mark question. And but in NDT there are, you must know the basic of different NDT techniques. Okay, like ultrasonic, dye penetrant, or liquid penetrant, magnetic, eddy current, etc. There are many radiography. Okay, there are many types of NDT, and you must know the basic idea of what happens, what type of defect is what we call, what type of defect can be observed in which type of technique, that you have to observe. In metal forming also there will be some theory questions like the types and the defects. Okay, defects in each type. Okay, for example, what are the difference in rolling, what are the defects in extrusion, what are the different defects in forming. Okay, all these are very important for matchings. And also some numericals can also be asked from rolling and extrusion. And also you have to have some basic idea like what are the different types of loading, what is direct compression, what is indirect compression, what is tension, what are the tension type of loading, and etc. All these are important in metal forming. Whereas in welding you have to know the basic theory of all the types: solid state welding, liquid state welding, gas welding. So all this stuff you have to know. And here coming to metal casting, this is again one of the important part. And here, okay, Chorino's rule. Okay, Chorino's rule is very important to calculate the time of solidification. Okay, so that is one of the important part. And also you have to know the basic sprue design, numericals also from this. Okay, so this is about manufacturing processes. Now if you see on a whole, okay, if you see on a whole, I'll be just writing down all the different sections. Okay, so now if you see, as I said, engineering mathematics will be about 13 to 15 marks. Thermo will be about 18 to 20 marks. Mechanical metallurgy will be about 14 to 15 marks. The same is with this physical metallurgy, and here there will be about 6 to 8 marks, and manufacturing will be of about 8 to 12 marks. Okay, so overall you'll be getting about 85 marks from these topics. Now the main thing is what topics to cover now, because we have very less time, and how to study and how to get good gate rank in by studying in these last 20 days is by picking up important. And okay, try to be smart. If you see here, thermo, and maths, thermo, mechanical and physical. If you concentrate on these four, then you will be getting about 60 to 70% covered on of this. But what I suggest is, don't try to go and finish off all the 100% syllabus of these individual sections. What I suggest is, do at least last 18 years previous papers, so that you'll be getting an idea of what subject or what section is easy and what section is difficult. Okay, so what I suggest is, go for thermodynamics. Maths, definitely you must concentrate on all the five topics because maths is a scoring part. Thermo, if you come to thermo, as I already said, try to try to cover heat transfer, electrochemistry part first. Whereas in mechanical metallurgy, as I said, try to concentrate on all the formulae first so that you can solve any type of question that is thrown at you. Whereas in physical, the important topics are crystal structure, liver rules, nucleation and growth, and also Bragg's law. These are some important topics. Similarly, in extraction, as I already said, the material balance problems, partition coefficient problems, and also you must know the basic idea about the extraction of important metals like aluminum, copper, lead, zinc, okay, titanium, etc. And whereas in manufacturing also I gave the important topics or important suggestions from my side. Okay, those are nothing but what you must study in casting, what you must study in rolling, okay, powder metallurgy, NDT, welding, etc. So now you must know what score you must be getting to secure a good rank. So according to me, a good rank is under AIR100, and if you do at least 50 to 60 percentage or 60 percentage, I won't say 50. If you give your 100% and try to attain 60% of the marks, that means 60 marks, you can attain a good rank. Okay, from 100 it is difficult to increase because the time is less. So if you are able to score and focus on 60% of this total syllabus, I guarantee you that you will be getting a good rank of under 100. Okay, so all the very best for your gate examination, guys, and also thanks a lot for supporting me and giving me 1,000 subscribers this fast within 2 to 2.5 months. So please hit the like button if you appreciate my work. Okay, appreciate my efforts. Please hit a like button and please share this video so that most of the gate aspirants will be knowing what to study, how to study, and what to leave. Okay, so always there is a slogan. I think everyone knows this. Hard work is important, but smart work will give success more than the hard work. So be smart and please study well. And I wish each one of you all the best for your GATE 2019 examination. So thank you guys. This is Avinash and you're watching Everything Metallurgy. Bye bye guys.